today we're going to talk about section 9.8, powers of complex numbers. Very similar to the multiplication and the division of complex numbers in polar form. It's going to have a pattern to it. And the pattern is going to look like this. Okay, so you've got a complex polar form of a number and it's raised to n power. What you're going to do is you're going to take that n and you're going to put it on the r value, and then you're going to multiply that n times the angle. So that's the form that working a power of a complex number takes. So here's an example. You've got 2 plus 2 on the square root of 3i. Well, the first thing you're going to go, and that's to the 6th power. You're going to go, well, that's not in that polar complex form. No, the first thing you have to do is put it into that form. So I'm going to take this. Remember, r is going to equal the square root of this squared plus this squared, which is going to give me a 12 here, because 3 squared, the square root of 3 squared is 3. 3 times 4 is 12. So r is going to equal the square root of 16, or 4. Then I'm going to have to figure out the theta. Well, theta is going to equal the inverse tangent of this, 2 on the square root of 3 over 2. They're both positive, so we're talking first quadrant. And when I do that, I find that that is the value that obviously I'm going to get the square root of 3. So at pi over 3, the tangent is the square root of 3. Okay? So now I can put it in that form right here. So I have 4 times the cosine of pi over 3 plus I times the sine of pi over 3. So once I get that, then I turn around and place this power on that. Okay? So now I'm at the point where I can actually apply this thing up here. So the very first thing I had to do was change it into the polar complex form. All right, now I'm going to apply this formula. So I'm going to take 4 to the 6th power, okay, this to this power, times the cosine of 6 times pi over 3 plus I times the sine of 6 times pi over 3. Well, 6 times pi over 3 is going to give me 2 pi. So 4 raised to the 6th power is actually 4096 times the cosine at 2 pi plus I times the sine at 2 pi. All right, so if I'm at 2 pi, the cosine is equal to 1. So I have 4096 times 1 plus the sine at 2 pi is 0, so 0i. 0 times anything is 0, so I'm going to do this and do this. So my final answer is going to be 4096, because when I multiply it times 0, I get nothing. If you want to write it as 4096 plus 0i, you can do that, but there's really no need for that. All right, I'm going to give you one to try. Remember, it's a pattern. Repeating the pattern, the power goes on the r, but then the power also gets multiplied by the theta value. Very first thing you're going to do is you're going to put it in the polar complex form. So go ahead and do this one. 1 plus I to the 5th power. Pause the video and then come back and make sure you got your answer correct. All right, r is equal to the square root of 1 plus 1. So r is equal to the square root of 2. The theta is the inverse tangent of 1 divided by 1, or where the tangent is equal to 1, and I know that that's at pi over 4. So I'm going to rewrite this. The square root of 2 times the cosine of pi over 4 plus I times the sine of pi over 4 raised to the 5th power. So I'm going to take the square root of 2 raised to the 5th power times the cosine of 5 pi over 4 plus I times the sine of 5 pi over 4. When I take that square root and raise it to the 5th power, I'm going to have, if you think about it, I'm going to have 4 of these, which is going to give me 4. So I have 4 on the square root of 2. If you did it out, just in case you're struggling with that, these two together equal 2, these two together equal 2. So I have 2 times 2, which is 4. 4 on the square root of 2. Okay, so that's what the square root of 2 raised to the 5th power. Then I'm thinking about where 5 pi over 4 is. It's going to be in my 3rd quadrant, so I'm going to have a negative square root of 2 over 2 plus I times a negative square root of 2 over 2. So when I multiply this, okay, this times this is going to give me a negative 4, and this times this is going to give me a negative 4. And remember the I goes at the end. So that would be the answer for that. All right, sometimes you have negative exponents, but they're all done the exact same way. So let's do one with a negative exponent. Let's say I have square root of 3 over 2 minus 1/2 I to the negative 5th power. All right, R is going to equal 3 over 4, because I'm going to square that, plus 1 over 4. So it's going to be 4 over 4, or the square root of 1, which is 1. My tangent, it's going to be a positive cosine and a negative sine, so you're talking 4th quadrant. It's going to give me a negative, let's see, inverse tangent of negative 1/2 over the square root of 3 over 2. And that's actually going to give me a value of 11, you can do phi or you can do theta, of 11 pi over 6, because it's actually a negative pi over 6. All right, so reworking it, I have 1 times the cosine of 11 pi over 6 plus I times the sine of 11 pi over 6 raised to the negative 5 power. All right, if it's raised to the negative 5th power, that means I'm going to place it over or underneath 1. And I'm going to do the same thing, but it's all going to be underneath 1. And then that's going to be to the 5th power. So 1 to the 5th power is 1 times the cosine. When I multiply that, it's 55 pi over 6, and we'll talk about that in a minute. And I times the sine of 55 pi over 6. All right, use some space here. 55 pi over 6 is equal to 48 pi over 6 plus 7 pi over 6. Now, 48 pi over 6 is the same as 8 pi, so that's 4 times around the circle. I'm not worried about that. What I'm worried about is the 7 pi over 6. So I can rewrite this as the cosine of 7 pi over 6 plus I times the sine of 7 pi over 6. Well, if I'm at 7 pi over 6, I'm in the 3rd quadrant. So my cosine is a negative square root of 3 over 2, and my sine is a negative 1/2, okay, because it's in the 3rd quadrant. What I'm going to have to do is I'm going to have to invert and multiply. Again, I need more space here. So I can rewrite this as 1 divided by the negative square root of 3, and I'll do it all over 2, plus negative 1i over 2. I'm going to invert and multiply on this, So this part's going to go on the bottom. So I have a 2 on the top, and I have a negative square root of 3 plus negative 1i. I got to get rid of the square root and the I on the bottom. So I am going to multiply by its conjugate. So negative 3, and if you look at that, that's minus I. So I'm multiplying by negative 3 plus I, the top and the bottom. All right, I'm going to erase this. So I can multiply this out. So I'm going to distribute. So I have a negative 2 on the square root of 3 plus 2i on the top. And on the bottom, I can do first and last because they're conjugates. So this is going to be a positive 3 minus I squared. Remember, you can't leave anything with an I squared. So that's minus a negative 1, or that's 4 on the bottom. So right now I have the square root, or negative 2 on the square root of 3 plus I, 2i, and then on the bottom I've got 4. So what I'm going to do is I'm going to reduce this down by 2 over 4. That's going to give me 1 over 2, so I have a negative square root of 3. Same thing here, plus I over 2. So I reduce by dividing that, and that by 2. All right, I'm going to give you one to try. Okay, go ahead and do it, and then come back to the video. R is equal to the square root of 2 plus 2, which is the square root of 4. So R is equal, or the square root of 4, which should be 2. So R is equal to 2. Your angle, it's going to be, the cosine is negative, the sine is positive, so it's going to be in the second quadrant. Okay, and it's going to be the inverse tangent of the square root of 2 over negative square root of 2. So basically you're talking the inverse tangent of negative 1, and you know it's in the second quadrant. So my angle is 3 pi over 4. So then I rewrite it. Okay, 2 times the cosine of 3 pi over 4 plus I times the sine of 3 pi over 4, and it's raised to the negative 2 power. That means I'm going to place this underneath the 1, and I'm going to raise these all to the 2 power. So I've got 2 to the second power times the cosine of 2 times 3 pi over 4 plus I times the sine of 2 times 3 pi over 4. I can rewrite that as 1 over 4 times the cosine of 3 pi over 2, because that's going to give me 6 pi over 4, which reduces to 3 pi over 2, times I times the sine of 3 pi over 2. When I do this out, I still have 1 over 4 times the cosine at 3 pi over 2 is 0. The sine at 3 pi over 2 is negative 1, so that's negative 1 times I. So basically I have 1 over, if you will, negative 4i. And I have to get rid of, I'm going to do it over here, or I'm going to run out of video space there. I've got 1 over negative 4i, which I have to get rid of the I on the bottom, so I'm going to multiply the top and the bottom by I, giving me what I over, I times I is I squared, so it's going to be negative 4 times negative 1, which is positive 4. So that's going to be my final answer for that. You could also write it like this. Okay, that's the same thing. All right, one last concept here, and that's with square roots, or you're finding the root of this complex number. But it's still a power, because if you remember right, the square root is the same as an exponent of 1/2. The fourth root is the same as an exponent of 1/4. So looking at this one, let's say I'm trying to find the fourth root of 2 plus 6i. That can be written as 2 plus 6i to the 1/4 power. Now I'm back doing exactly what I was doing before. So let's find the r, so the square root of 4 plus 36, or the square root of 40. I probably would break that down into 4 times 10, or 2 on the square root of 10. Your theta, it's going to be in your first quadrant because both your cosine and your sine are positive. So it's the inverse tangent of 6/2, which is 3. So I have the inverse tangent of 3. If I do that out on my calculator, and I don't know that on the unit circle, so I can do it on my calculator, but I need to be in radians. And it's going to give me a value of 1.25, which is something that we can definitely work with. All right, so rewriting this, I have 2 on the square root of 10 times the cosine of 1.25 plus I times the sine of 1.25. And then, of course, I'm going to put the power on it, so it's going to be the 1/4 there. So this is going to be 2 on the square root of 10 to the 1/4 power times the cosine of 1/4 times 1.25 plus I times 1/4 times 1.25. Okay, and I'm going to have to work that out when I do this, and I'll do that on my calculator. That is equal to 1.59. This is equal to, and if I just take that whole value and put it in my calculator, remember in radians, it's 0.9516 plus this is 0.3074i. Then I multiply this times this and this times this, and I get 1.51 plus 0.49i. Okay? All right, you try one, and then I'll give you your homework. So I have the cube root of 8i. Okay, go ahead and do it out, and then come back to the video. This is the same as 8i to the 1/3 power. So over here with the r, the x value is 0. So that's the same as the square root of 64 because it's 0 plus 64. So I know that my r is equal to the 8. My theta, I'm looking for where I have a cosine of 0, but then I have a sine value, okay? And the sine value is positive. So I know I'm looking at pi over 2 because that's where my cosine is equal to 0 and my sine has a positive value. All right, so I can rewrite this as 8 times the cosine at pi over 2 plus I times the sine at pi over 2 raised to the 1/3 power. So I have 8 to the 1/3 power times the cosine of 1/3 times pi over 2 plus I times the sine of 1/3 times pi over 2. So the 8 to the 1/3 power is the same as 2 because it's the cube root of 8 times the cosine at pi over 6 plus I times the sine of pi over 6. So I have 2 times the cosine at pi over 6 is the square root of 3 over 2. The sine at pi over 6 is positive 1/2. So when I multiply here, I'm going to get the square root of 3 plus just simply I, because it's going to be 2 over 2. And that is going to be my final answer. All right, your homework. Is page 605, 12 through 24, all.